By solving this question, your concepts for continuity and differentiable will be crystal clear. So let's try to understand the question first. So show that the function f of x is mod x minus 4 mod x belongs to R is continuous but not differentiable at x is equal to 4. First, let's try to understand what is the concept behind to prove it is continuous and differentiable. If we have to prove f of x is continuous, we need to prove that LHL is equal to RHL is equal to f of a. So what limit you are taking? So for proving continuous, we need to prove that LHL at x is equal to a and RHL at x is equal to a is equal to f of a value. So here we will apply limit x tending to a minus f of x should be equal to limit x tending to a plus f of x is equal to f of a. So we will one by one we will put the value of x in LHL and RHL and directly in f of a. So this is how we need to prove whether a function is continuous or not. Now to prove f of x is differentiable, we need to prove that LHD is equal to RHD. Left hand derivative is equal to right hand derivative. From so this we have to prove that limit x tending to a minus f of a minus h minus f of a by minus h is equal to limit x tending to a plus f of a plus h minus f of a divided by h. Using these two concepts, we will solve this question. And I'm sure that if you have learned these two concepts, it will be very easy to solve this type of questions. So now let's begin to solve this question. First, we have given a function f of x is equal to mod x minus 4. So we know the mod function. So we will write here f of x, three parts. It will be mod, this function will be x minus 4 if x is greater than 4. It will be 4 minus x if it will be like x is less than 4, and it will be 0 if x is equal to 4. We know the mod function, right? If x is greater than here, if f of x is mod x, then x is equal to 1 if x is greater than 1, x is equal to minus 1 if x is less than 1, and x is equal to 0 if x is equal to 0. Okay, so this was concept. Now we need to prove first that it is continuous at x is equal to 4. So now for proving, we need to prove first f of, what is f of 4? F of 4. Now by looking into these conditions, when x is equal to 4, then f of x is 0. So when we are putting the value of 4, we are getting the value as 0. Now LHL. To prove, what we will write here, limit x tending to 4 minus f of x. So limit x tending to 4 minus, you will write here 4 minus, so x is less than 4. So you will write here 4 minus h. Okay, then you will write here limit h tending to 0, 4 minus 4, which is equal to 0, because 4 minus 4 is 0 and limit of a constant is constant itself. Now we'll go for RHL. Here limit x tending to 4 plus f of x will be equal to limit x tending to 4 plus, see here, x is greater than 4, little bit greater than 4. So what is the function we have to use? X minus 4. If it is less, we have to use this. If it is greater than, we have to use this. So it is x. For x, what we have to put? 4 plus h minus 4, which is equal to limit, because you know we have to write x minus 4. So what is x? So we'll write here 4 plus h minus 4. Okay, yes. Now limit h tending to 0. See here, 4 minus 4. Okay, so I think I have missed here h. Now it's okay. Now 4 minus 4 cancelled, and h, so here it will be 0, so answer will be 0. We could see that LHL is equal to RHL is equal to f of 4 is equal to 0. Hence the given f of x is continuous at x is equal to 4. Now we will apply some conditions for differentiable to prove that the function is differentiable. Now let's do that. Now to prove for differentiability, we need conditions. We need to prove the conditions that LHD is equal to RHD. So we'll follow these functions only. So LHD limit x tending to 4 minus, see here, x is less than 4, so we will use this function. First, let's write the formula for LHD. For you will write 4 means a minus h, f of a minus h minus f of a divided by minus h. So a value is 4 here. So we'll put this function a minus h. This is the value of x. We will put in this function. So limit x tending to 4 minus f of a minus h, 4 minus of a minus h minus, see here, f of a value is 4. We'll write here 4. 4 minus a value is 4. So 4 minus h. Now f of a value is 4. So if we are putting x is equal to 4, their function is 0. So we'll write here 0 divided by minus h. If we will simplify it, limit x tending to 4 minus, you can see here 4 minus divided by minus h. So this and this will be cancelled, and this will be cancelled. So we will be getting limit x tending to 4 minus 1, and limit of a constant is constant itself. So we'll get minus 1. Yes. Now we will go for RHD. For RHD, we need to prove that f of a plus h, limit x tending to a plus f of a plus h minus f of a divided by h. So a value is 4. So what we will write here is limit x tending to 4 plus. So instead of x, we have to write 4 plus h, and we have to use this function, the first function. Okay, so what we will write here, 4 plus h minus 4, and f of 4 is 0, we know, and we'll write h here. If you will simplify it further, you will get 4 plus h minus 4 by h. 4 cancel, and h will be cancelled, and the limit of x tending to 4 plus h by h, you will get 1. So limit of a constant is constant itself, you will get 1. You can see here that LHD is not equal to RHD, because LHD you are getting the value as minus 1, but in RHD you are getting the value as 1. So we have proved that it is not differentiable. It is not differentiable. The given function is not differentiable.